the mechanical principles of this, as I said earlier, are very, very similar to tapering. If you consider this, it's pretty much tapering in a single plane, so you're allowing it to spread out in the other plane. How you approach that movement of the material with your hammer becomes important depending on what you're trying to do. So if you are trying to just get a fishtail, you want that hammer blow to come back into it so that you're pushing the material back in to get it to spread. If you want it to just get a little narrower but flatten out more in a linear direction, you might put the heel in ever so slightly and cause it to push forwards, which will give you less horizontal movement. So understanding what is happening with your hammer blow, whether it be a dead flat hammer blow, whether it be a slightly angled side to side hammer blow, heel in or nose in, depending on your final construct is important. So don't just do the thing thinking that it's always the same. Basic fact is, if you come straight down, you're going to get a very, very similar result every single time. If you start manipulating the hammer blow and the hammerhead, you're going to create variances that will give you different results. Due to technical issues, we will reshoot that department. So, when you're coming in on the tip, you are going to be doing more of like a pulling hammer blow where the hammer is coming in towards you. As you come in, working left to right, you'll actually notice that you get almost an upsetting forming here. So it actually gets thicker right up at that shoulder. And the other position it will come in at would be heel in to cut in an isolation. You could also do this off the edge of an anvil like this with a flat hammer blow, half on, half off. But for this case, heel in. You'll notice with this style of hammering, because it is essentially a pushing and a pulling, you're not going to get as much width. Okay? And back to our normal programming. This way, shall go this side. Turn the hammer this side and push in, and almost use that like a fuller. Same that way. That is going to get me more side to side movement. With that in mind, I can turn this way and pull with that material, still hitting with a flat hammer blow, and drag that material out to the side. See how that pulls out. And if I wanted to go this way, I could theoretically push it and just find that mass and keep pushing it out. But by manipulating how your hammer blow lands and what it's actually doing, you can yield greater widths. And again, this is one of those things that you're never going to yield a mathematical width. If you are dropping 1 inch wide to half material thickness, you're never going to yield 2 inches. The material just won't do that for you. You're always going to get forward movement. But you can guarantee to get about 50% of the width. So keep that in mind. I'm going to come in, do this similar kind of thing with the hammer on the hot material. Hopefully you'll get to see what happens. So, straight in at the tip. This is a pulling hammer blow. And you'll see how little width I've yielded there compared to the previous one. But vertically, I've actually gained a little bit of thickness. So you might be able to see that across this shoulder right here, that it is slightly wider than here. It's not a huge amount, but it is something for sure. Okay. I'll take another heat, come in more with the heel of the hammer. It's going to be a little awkward because of the bar getting in the way, but hopefully I can get in like that and create a shoulder or a set down using that hammer face. I could come in with a fuller, cut a line in there with a fuller, or a set hammer or something like that. I could also put it off the underside of the anvil and place that mark in from the underside of the from the near side of the anvil, so it's cutting in on the underside. But I'll save that for some variances later. Understanding what your hammer face does, how that movement occurs, just by changing how this face interacts with the surface, whether it be this way or this way, and also the angle of force. If you just come straight down, it should give you an evenness like this. But if you're creating more of a sliding motion or a pushing motion with that hammer face, you are going to manipulate how that material moves slightly. Right, let's see if we can drop that heel in a touch. So you can see, come in, similar thickness to there, but you can tell that this one's slightly thicker, that's why it's turned this way more. But you'll also see on this, it hasn't yielded that great width. The previous fishtail, I'm just going to grab it out of the water bucket. Previous fishtail that I did was quite considerably wider, and that's just because of how the force came into the material. So always remembering what is happening with the force of your hammer is important. You know, there's a lot of different ways to throw this thing at a piece of hot material, and you know, the Hoberman or Hoffy style or Brazil style, where they're using the edge, the heel and the nose of the hammer as a dynamic fuller is absolutely applicable. I don't use it a whole lot, but I definitely use the different portions of my hammer face. So I'll slide into this lower radius to be able to push with it, or slightly to the side to rake out material left and right, treating this more, that small radius there, as a fuller rather than just a flat face of a hammer. If you were striking with a truly flat disc, that's going to do a completely different thing. You're almost going to get printing, and that whole thing will go out. And then you've got to do a series of printings to get that material to push evenly out to make a nice flat surface. Maybe we'll do that on the press later as an example of kind of more of a mechanical style approach. Right, I'm going to use that outer edge to pull out this way. Right, and you'll see I've thinned the material in the center line here. I might have pinched a little extra from that side, but give or take, it's about center line. It's slightly thinner here than it is on the outer edge, but I still have a lot more material thickness on that edge, which will rake out to be the width. So I can actually get a greater width by doing that, okay? So I'm gonna keep flattening this out a little over here. We'll see how that material moves out. And what I'm hoping will happen is, because I have done a compressive work on the front here, which has created little flaring, and I've done essentially compressive work this way as well, which has only created a marginal amount of flaring going that way. Then, because I'm chopping this in lines, it should swell out more like that. And then when I come to this side, I'm going to do that with a pushing hammer blow and hopefully get a similar effect going in that manner. We'll see, but I'm hoping that that will illustrate the mechanics of what the hammer is doing, how you approach that force into the flattening surface. So I'm still going to keep using that outer corner. And you can see how the edge of the hammer, it actually prints into the steel ever so slightly. It creates an unevenness. I'm now going to just come through with a little light flattening. Okay. Got a little bit of a wily hammer blow there. Okay. Do the same over on this side. So this time it'll be a pushing hammer blow. I won't be putting the heel in so much as I'll be striking with the center of the face, but instead of the force coming down straight like this, it'll be coming in at an angle. So it'll actually look like a little bit of a brushing stroke, which it is. That, in doing, if I come down at about 45 degrees with that impact, what it will do, it will compress and push that material out.
When you say a brushing stroke, just to be clear, you don't mean just brushing the surface, you're still trying to do a penetrating hammer blow?
Yeah, so as I come in, my point of impact is coming at about 45 degrees. If I go any flatter than 45 degrees, I'm not getting sufficient energy transfer into the anvil. You start getting it kind of sliding off. You'll notice that the material will try and run away from you if you're pushing too much. So I'm still going into the anvil, but because I'm coming down more to 45, it will be bouncing out like that, and the hammer blow will have this kind of rotary motion to it. Alrighty. I'm running it in lines, starting in that center mass. Also notice that that style of hammer blow gives you generally cleaner work as you're going through the process. You remember this one was leaving quite heavy markings, where this, it's just kind of your standard hammer face marks. So you see how I've got very, very similar width formation from those two things. And you can see at the tip where that first line was laid in, you can almost see that coming back through here. Almost created a semi-formation of the center ridge.
When you turn it like that, you can see it.
Edge material thicknesses are still very similar. So essentially that's shown you the effects of a few different hammer blows, how they affect the movement of the material. Hope it'll make you think about how that hammer blow is coming down in the future. So often I'll see people do things in classes and they're not really thinking about what it is truly doing. Each hammer blow should have a thought or a principle behind it. What is your intention for this hammer blow to be doing? Am I trying to get it to break this way or this way? Am I trying to get the material to progress this way or this way? If you're just slugging away at it, you will probably achieve a thing, but it will not be as intentful and thus more efficient. Okay? I'm going to chop that off and do another video.